Hi, so today I want to go over logarithm rules and how to use them and show some examples with them. This isn't so much going to be a video explaining the intuition behind why these work, but it's more or less like a study guide on if you encounter a problem, how you can solve it quickly just by looking at this guide. So here we have three rules. We have log AB is equal to log A plus log B, and then log A over B is equal to log A minus log B. And then finally, we have a log b is equal to log b to the power of a. And we're going to go through these one by one, and then we'll solve a problem where we have to use all of these rules. So let's look at our first example. So what does log ab is equal to log a plus log b mean? Well, if we had a problem that said something like log 8 plus log 2, what would this be equal to? Well, we can plug this into a calculator, but if you just wanted to simplify and write this as one logarithm, we could follow our rules. So if we have log of some number plus log of another number, we can multiply them. So we can include them in one logarithm, and so 8 times 2 is equal to 16. And this only works because they all have the same base. So if we have a log right here and there is no base, that just means that there's a base of 10 there. So let's say we had log 2 of, say, 16 plus log 2 of 2. What would that equal? Well, we can still follow our rules. You might be able to solve this you may be able to solve this using mental math, but let's just convert this into one logarithm, right? So our log is going to stay the same and our base is going to stay the same. And now we just multiply whatever our numbers in the parentheses are. So 16 times 2 is 32. And we know that this is true because log base 2 to 16 is 4. And then log base 2 of 2 is going to be 1. So 4 plus 1 is 5. And then log base 2 of 32 is going to be 5. So 4 plus 1 is equal to 5, and 5 is what log base 2 of 32 is. Okay, our next example is going to be the opposite. So we added two logarithms with the same base and multiply. Now we're subtracting two logarithms with the same base, and now we're dividing them. So let's say we have log 10 minus log 5. This we could just rewrite this as log 10 over 5. But we don't want to stop there. We want to simplify. So we would say this is log 2. And let's think of another example where we have a different base. So let's say we have log base 3, 81, minus log base 3 of 9. And this would equal log, our base stays the same, 3, 81 over 9. And then again, we can simplify this to mean log 3 of 9. And then let's actually solve this. So log 3 of 81 is going to be 4. And then log 3 of 3 is going to be 2. So 4 minus 2 is going to equal to 2. And then our answer is going to be log 3 of 9, and that's going to equal to 2. So 4 minus 2 equals 2, which is our answer on this side of the equation. So we know that this is correct. And now for our third rule, we have a log b is equal to log b to the a power. So all this means is that anytime we have a logarithm, anytime we have something that looks like log 2 to the 4th power, we could just rewrite this as 4 log 2. Because sometimes we don't want to deal with the exponent inside of the parentheses. So sometimes we don't want to deal with the exponent inside the parentheses. We already have too much going on. So all you would do is just move the exponent as a coefficient at the beginning of the log. and this is still valid. So another example could be like, let's say log base 2 of 2 to the 4th. Well, that can be log 4 log 2 to the 2nd, right? And this is going to be equal to the same thing. So 2 to the 4th power is going to be 16, and log base 2 of 16 is going to be 4. And then we have, so what is log 2 of 2? Log base 2 of 2 is going to be 1. And then 1 times this coefficient 4 is going to equal to 4. So these two are equivalent. So now let's look at an example where we have a problem where we have to now simplify this into one single log, right? And we know we can simplify this into one simple log because all of our log here's have a 5, right? There's a base of 5. So we know we can condense this down all into one single logarithms. So let's start. Let's start at the beginning. So we have 2 log 5 of 2 log base 5. So we have 2 log base 5 of m. And in this case, we already have the third rule, right? Where you have the coefficient in front of the log, and we have m in our parentheses, where 2 would be the exponent. So in this case, because we do want to condense it, so let's go ahead and place the exponent back. So we're going to rewrite this problem as log base 5 of m squared. And we're going to do the same thing with this other log. So plus 3. So actually, we're just going to write log base 5 of k to the 3rd power, right? And then we can go ahead and do it to this one as well. So we'll have log base 5 of y to the 8th power. Great. So now we can start applying our multiplication and division rules for these logarithms, or in other words, our addition and subtraction rules. So if we have a logarithm with the same base plus another logarithm, so if we have one logarithm with the same base plus another logarithm with the same base, all we have to do is just add them together, right? So log base 5 of m squared plus log base 5 of k to the 3rd power, we can simplify this as log base 5 is equal to m squared times k to the 3rd, right? And now let's bring this down. So we have log base 5 to the y to the 8th. Log base 5 of y to the 8th. Okay, so now what do we do from here? So let me just go ahead and move all of this up so we have more space. Okay, so what do we do from here? Remember, when we're subtracting logarithms, now we divide them. So we can simplify this as log base 5 of m squared k to the 3rd over y to the 8th. And this is our final answer. So as you can see here, all we did was, the G didn't get attached. Okay, so all we did was we took our original logarithm problems, and added this coefficient back as an exponent to all of the terms. And then from there, we just use our our addition and subtraction rules, right? So if 2 logarithms are being added together, you multiply them. And if 2 logarithms are being subtracted, you divide them. And then we get our final product right here.